Coming back real quick, number 15. Using this figure above, state the theorem that justifies the statement. Angle ATR, that's this angle right here, is equal to the measure of angle TAC plus TCA. So angle 1 equals angle 2 plus angle 3. That is called the exterior angle theorem. So we'll complete this proof. XY is congruent to XZ. Let's go ahead and mark that down. It was given. BD bisects angle YXZ. That's supposed to say XM, not BD. So if that's an angle that bisects the angle, that means these two angles are going to be congruent. We don't have to write that though. We can mark it, but it's not written down here anywhere. So the next thing, it says that triangle YXZ is an isosceles triangle. YXZ is isosceles. We know it's isosceles because we just said that these two sides were congruent. And that's the definition of isosceles. So you could say two congruent sides, or you could say definition of isosceles. Definition of isosceles, or just say two congruent sides. That's good enough. So now we've got this reason, we have to figure out what the statement was. An angle bisector to the vertex angle. We just said that XM was an angle bisector. Is also a perpendicular bisector to the base. So if XM is the angle bisector, it's also the perpendicular bisector of the base. So XM is a perpendicular bisector to the base, and the base here is YZ. So XMZ is a right angle because we just marked it because it's perpendicular. Definition of perpendicular. And then since it's a right angle, that means it's 90 degrees because that's what right angles measure. Now we'll go through these other review questions that go from previous frameworks. Find the equation of the line in slope-intercept form that passes through that point and is parallel to this line. So if it's parallel, it's going to have the same slope. So let's first get the slope from this. So we're going to change this to slope-intercept form. Y equals mx plus b. So we're going to solve it for y. So let's move the 5x over. Subtract it over. And then we don't want negative y, so we're going to change all the signs. And now that's slope-intercept form. The slope is positive 5. Since we want parallel, we're going to keep the same slope. And we're going to use this point, 7, negative 8. We'll plug that into point slope, which is y minus y1 equals m x minus x1. So we go y minus negative 8 equals m, which is 5, x minus x1, that's 7. So let's distribute. We get 5x minus 35 equals y plus 8. and then finish it off, subtract the 8. You get y equals 5x minus 43. Given a segment, we know the coordinates of A and the coordinates of the midpoint. We've got to find the coordinates of B. So midpoint formula says x1 plus x2 divided by 2, y1 plus y2 divided by 2. That's the coordinates of the midpoint. So we know one endpoint is 3, negative 5. The other endpoint we're just going to call xy. So you take our two endpoints, plug them into the formula, and that gets us the midpoint. So 3 plus x divided by 2, and negative 5 plus y divided by 2. So we plugged in our endpoints. That's what the midpoint's going to be. In order to solve for x and y, we're going to take that the midpoint is 5, negative 1. That means this has to equal 5, and that has to equal negative 1. So we have two little equations going on. And negative 5 plus y over 2 equals negative 1. And you just solve both of those. So when you solve, you're going to multiply by the 2 to get it off the denominator. Same thing on the other side, the other equation. So we have 3 plus x equals 10. Subtract the 3, you get x equals 7. When you multiply over here, you get negative 5 plus y equals negative 2. Add the 5, you get y equals 3. So there's our x and our y, 7, 3. Put it together as a point. And that's the other endpoint we just found. The members of the family of lines having the equation y equals negative 4x plus a. So this plus a kind of changes we'd have to distribute this out, and it would change the y-intercept. The thing that never changes is this negative 4 that gets multiplied to the x. And the number that's always multiplied to the x is the slope. So these all have the same slope. That's the number that's not changing. The y-intercept would be changing. Which two rigid motions explain why vertical angles are always congruent? So these are vertical angles right here, 1 and 2. You can explain that they are congruent with a reflection. Or a rotation. You could rotate it around and match up the angles. Which two transformations are performed by this rule? So we can see that the x and the y change places, and then there was a negative x when we flipped it around. So just from that bit of information, we have it is a rotation and y negative x is 270 degrees counterclockwise. But that's not all. There's also that 3 right there, the minus 3, which is a translation. Which transformation is defined as a transformation along a vector, such that the segment joining the point and its image have the same length as the vector and is parallel to the vector. The vector means it's just a slide. It's a translation. Vectors are always translations. When using a compass and straight edge to bisect a segment, you place the point of the compass on A and open the compass how far? More than halfway. More than halfway from A to B. Draw all 6 lines of symmetry. Ooh, let's get better lines than that. There's one. There's one. There's one. We can also go from these inside points. All of those are lines of symmetry. You can fold them over and match up the shape. And find all the angles of rotation that will map the figure onto itself. So you just count how many points would match up. So we have 2, 3, 4, 5, 6 points that can match up. So you take a full rotation of 360 degrees, and it's going to be split up at those 6 points that would match. So you divide. You get 60 degrees. So every 60 degrees, it maps onto itself. So at 60 degrees, or 60 plus 60 more is 120. Another 60 is 180. Another 60 is 240. Another 60 is 300. And then another 60 will be 360 degrees, which is a full rotation. We don't have to write that one down.